In this video, we are going to look at API Gateway in depth. The agenda goes like this. We will briefly look at what is API Gateway. We will in depth look at what are the internal components or the features of the API Gateway. I'm going to list down all the features of the API Gateway and we are going to discuss each of them with an example. We also will discuss why do we need an API Gateway in the first place. I'll show the need of that using a case study, using a food delivery app system design. We have seen that system design as a separate video, but I'm going to use the same design to show how API Gateway is going to help us there. Finally, we will look at what are the different tools and the platforms which are available for managing your APIs. I also wanted to introduce a trivia question that will be very helpful in your system design, interviews, or understanding about API gateways. Do watch the video till the end to know what is that particular question. And obviously, you can enter the answer in the comment section below. I will respond to each of your comments and let's validate our understanding. So, what is an API gateway? So, the bookish definition of an API gateway is API gateway is a crucial component in the modern IT environments that facilitates communication between clients and the services. This essentially means when we talk from one service to another, when there is communication between one service to another over an application programming interface or an API call, right? We need an API gateway to facilitate the management of, to make the communication better between these services and also to better manage the whole environment as such. Now let's go deeper into API gateway by understanding the different components of the API gateway. Obviously, the API gateway's primary responsibilities with respect to APIs. So we will have a lot of API specific management, which are the first boxes. There is also traffic management, security, observability, and traceability. And also there are other features which we are going to look at. We are going to see each of these individually. Now let's get started with the APIs first. With respect to API, the major features which API management system or the API platform provides is specification, aggregation, transformation, and caching. Let's look at what is specification. With respect to specification, generally we write API specs so that when, let's say, I'm designing a backend application, I want to communicate my response types, response codes, or even the model or the request which I expect from the downstream or my upstream, right? So what we do, we create a documentation around my API. So what we started doing is we started writing specification for it. We started writing API specification using YAML, and that gets converted or translated into real code and also documentation. One classic example is the Swagger specification or Open API specification now, which we commonly use. So API gateways can facilitate usage or hosting specifications for specific APIs. The next one is aggregation. Sometimes we have multiple services behind an API gateway and we want to aggregate the response from two different services into a single API call. For example, in this case, a user or a client is requesting the API gateway to give information about a particular user and the credit the particular user holds. In the backend, API gateway does two different calls, one to the service user, which is getting user information, the other to the payment information, which gets the credit information about how much the user holds. So there are two different API calls which are done in the backend, and those two responses are aggregated and then sent to the user as a single response. From the user's perspective, it's a single API call or a single request, but underneath we have done multiple calls and then we have aggregated. So API gateways can do aggregation as well. The next one is transformation. As the name suggests, sometimes we want to respond to the user with respect to specific messages, or we want to replace a particular string from the message which we got from a service. So there are different ways in which you can modify the transformation logic. So if you see here, one such logic is find and replace a string in the body. You can also sometimes convert a JSON message to an XML. For example, our downstream is expecting XML, right? But the services are returning JSON. Then API gateway can do the transformation of JSON to XML and then send it, right? Still, maybe it can expose another endpoint, or maybe using a header, we can control saying you can still respond with a JSON and also a XML in the same APIs. Right? Likewise, there are different options in terms of setting HTTP headers or request methods or query string parameters, which are like transformation policies, which can be set at the API gateway level. So API gateway provides and facilitates that as well. The next one is caching. In order to make our APIs efficient, there is also caching which is provided by the API gateway. So using a header, we can control how long that particular message can be cached. For example, here we have set a cache control to say that the max age is 300 seconds, which is 5 minutes. So the response can be stored for 5 minutes in the cache. And if let's say I get more get calls, I will be able to respond with that particular message from the cache. So API gateways help in terms of caching some of the information as well to reduce the load on the downstream service. Of course, you need to handle these cache with care. You cannot use cache blindly. Instead, you can use it when you have read heavy systems and you know that there is no problem with respect to if the cache is not refreshed within 5 minutes. The next one is the traffic management. In the traffic management, we again have different features. The first one is routing URLs. The primary goal of a traffic manager is to route traffic based on the URL path. So we can have a different path from the user to a API gateway, and underneath you can have a different path. So for example, we can create routing rules based on specific parameters, and you can route it to a different endpoint or a different host, etc., within the API gateway layer. For example, I'm exposing a api.food.com, and underneath I can redirect those requests to /restaurants or maybe to another URL or a domain, right? So API gateway can do traffic management by routing it to different URLs as well. The next one is API versioning. Of course, this could have been there in the API versioning concept, but then we use it for traffic management. Again, depending on the type of API call, we can control the version of the API or the version of the instance of the application which is running. For example, within an API gateway, there are API registries and there is service discovery. So whenever an API is registered, for example, in the background, we have some downstream services. Let's take an example of a restaurant service. We have a service called restaurant service. Here it is defined as instance of service one. So this restaurant service needs to be registered with the API registry so that everybody knows that, okay, there is a restaurant service which is hosted. So API gateway knows that, okay, there is a restaurant service which I need to register traffic. Now API service discovery will go and identify the instances which are running for that particular restaurant service. So notice here there are two different versions of the application which are running. So these could be because I have V1 version of the API which has some specific model or maybe some specific feature. V2 could be an advanced version. I didn't want to break that backward compatibility, so I have two different versions of the API as well. So the API discovery service will help us in identifying these services, and the routing logic will help in terms of like identifying which version we need to route it to. So versioning is another concept where you help the traffic manager to control what version of the API is being called and what version it needs to redirect that particular API call to. This is another predominant feature which a lot of folks leverage from the API gateway. The next one is, of course, load balancing. API gateway internally does load balancing as well, but of course, load balancing can be outsourced to the external world because API gateway does a lot of different things in addition to load balancing. So the primary job of API gateway resides outside of the load balancing scope, but then I'm just listing it here because it also does traffic management. So API gateway can identify different services. Again, like I showed, there is service discovery. Using service discovery, it can identify these services and then route traffic to the service which has the least number of requests going through. So there could be different logics. You can apply logics like load balancer. So the same thing is embedded in the API gateway. The next and the most predominant one which we use is the rate limiting or throttling. API gateway helps us in controlling the traffic by filtering out some of these requests based on the load configured for a particular API. Sometimes people start abusing the system by sending too many requests. At that time, we want to control and safeguard our services, and that's when we use rate limiters or throttling mechanisms. And these all can be controlled by API gateway because those are all primary features of the API gateway. If you see my channel's videos, I have a lot of videos around throttling, load shedding, and rate limiters. If you're interested in trying them out, do check those videos as well. Again, next one is the circuit breakers. We use circuit breakers for fault tolerance. We have implemented circuit breakers with a lot of Resilience 4J APIs or even the Netflix APIs. So circuit breakers are also embedded within the API gateway. They help respond and open up circuit or close the circuit by controlling the traffic to our microservice from the API gateway layer itself. And in addition to it, we can configure retry policies and exceptions which are allowed in the API specification itself. So when we write an API specification and give it to the API gateway can understand from that specification how long it needs to be retried, what is the configuration for when the circuit should be open. Let's say we get a 500, the circuit should be open, or if it is 429, the circuit should be open. We can control all that, and we can also provide retry mechanisms and the policies for the same. So API gateway can internally do a retry, so the client doesn't have to do a retry. For example, a client does a call to a microservice via the API gateway, and that particular microservice is returning 500. Maybe at that point in time, the microservice was having some issues. So what the API gateway will do is the API gateway will retry, because here we have configured retry mechanism as 4, right? So it can retry 4 times, and then the duration is 2 seconds. So the response waits for the customer, and then from the API gateway, we do retries mechanism for every 2 seconds 4 times. If something succeeds, then the response is sent back to the requester. Otherwise, we keep on retrying until the configuration of the threshold is achieved. So circuit breakers help in controlling the traffic for our service. So these are all the features which are specific to the traffic management. Coming to the security aspect of things, so security is a very key factor in using API gateways. We don't have to have authentication and authorization in every microservice. We can have and then offload that to an API gateway. So API gateway, if it is an entry point for any microservice to be called, then it can enforce the authentication and authorization mechanisms. You can leverage different mechanisms like OpenID Connect, or maybe federated login, or JWT based logins, etc. So API gateways in general support security as a first class citizen. So you can definitely leverage security mechanisms, and also some of the API specifications can be modified to have controls on authorization, roles, etc. So API gateway can be tweaked in with the specification to add these with the configuration itself. Another security feature which we can leverage API gateway for is anomaly detection. Since all the traffic is routed via the API gateway, we can easily snoop into that particular traffic and identify if there is any discrete patterns, to identify if there is any attack or something fishy which is happening in the system. So you can use security teams leverage API gateways for identifying if there is any anomaly happening by looking at the logs, traces, or metrics from the API gateway. And it also helps in securing the APIs whenever we require or need to shut down that particular API. Coming to the most critical part of the API gateway, observability and the traceability. So there are 4 major pillars of that. The first one is metrics. So we can publish metrics from the API gateway directly. So we don't have to have any code present in the application, but we can leverage API gateway itself to have some metrics which are specific to the APIs. So in this case, I'm just showing the request count. So the request count can be published from the API gateway, and also the number of errors which are, or the response codes can be published for individual requests from the API gateway itself. If you need any application specific metrics, obviously you have to publish from the application code, but these are API specific metrics which I want. So API gateway helps us in identifying the incoming traffic, outgoing traffic, the error response codes, etc. from the gateway itself. So we can use API gateway to publish metrics, and using the metrics we can of course create dashboards. This is one sample dashboard where you can use the API gateway data and then create beautiful dashboards to identify issues in the system. And using these metrics we can also create alarms. So for example, if I want to notify or create an incident based on some response codes, for example, if I get a 4xx or a 5xx, I want to create an incident, right? And if let's say it's happening every 5 minutes, right? So I want to like create an incident. So I can definitely configure API gateways to have alarms on top of these metrics, right? So observability is a key part of API gateway. And finally, logs. API gateway can provide us the request response logs. So we can even use these logs to create maybe alerts, or maybe like scrap through them for any debugging purpose or mitigation of issues and things like that, right? So those are the key features for the observability and tracing aspect. The other additional things which we discussed earlier was the auto discovery. So I showed about the auto discovery of how you can identify the instances, but the primary usage of an auto discovery comes when we use a health check endpoint. So individual services will have health check endpoints. When they register with the API gateway using the API registry, they configure the health check endpoints, and using health check endpoints we check the status of that particular API and the services which are up and running. right? So we will be able to get a consolidated health check information about individual services behind the API gateway as well. So those are the major features which API gateway provides. And if you see, I don't have to now justify why we need an API gateway, because you saw we have centralized API management using which we controlled a lot of API specific features. We had security in the API gateway itself embedded, so you don't have to have security in every service. We also have traffic management with respect to managing the traffic for the APIs using rate limiters or circuit breakers, etc. We also saw how we can trace our requests, add metrics, and then publish alerts if there is any deviation from our metrics using the observability features. So these are the reasons why people adopt API gateway, because they provide tons of valuable information. Now let me show that with an example. Let's imagine that you are a developer in the food delivery platform like Zomato, let's say, right? This is the architecture diagram which we saw when we built the system design for food delivery application. If you didn't watch that particular video, I would suggest you to take a look at that particular video. I went through each and every part of it. There were two videos in that series, part 1 and part 2, which talked about how you can design a food delivery system from scratch, right? We also saw how we can handle the failure transactions, rollback transactions, and things like that. So this is how the system design looks like. I'm not going to walk through in depth, but know that there are multiple moving parts. There are multiple microservices in the system. So when they interact with each other, every system needs to know about each other, right? So restaurant service needs to know about the cart service needs to know about the order service. And if, let's say, I change one particular IP address or one particular load balancer URL of a cart service, then I need to change in the mobile application, I need to change it in all other places. Classic example is, if I change it for order service, I need to touch many other services to flip the URL or maybe use a new URL or a path, right? Now we can offload all those into the API gateway. If, let's say, I create a api.food.com, every system will use the same URL, api.food.com, but the routing logic will be different. So you can have api.food.com/restaurant for the restaurant service, /cart for the cart service, /order for the order service, /payment for the payment, etc. Right? So from the user standpoint or the client standpoint, you will know that, okay, it's just a single URL, which is api.food.com, but underneath you will have different routing logic. We look at observability. Maybe if, let's say, if we are in Zomato, I mean, we would have created a dashboard like this for observability, right? Where we can identify how the VMs are running, what is my inbound and outbound traffic from the VM, how many discretes are present, etc., etc. This is just a sample dashboard, but we can create n number of dashboards with the information which we have from the metrics which we collected from the API gateway. So that's how useful the API gateways are in developing critical systems, and that's why you see API gateways all across the board. Now, coming to the tools which folks use in the industry, some of these tools you would have used it, starting with APG. It was a product from Google. Again, it was a separate product. Google bought it. There are cloud-specific products like Amazon API Gateway or Azure API Gateway or IBM API Connect. There are standalone products like Kong, Boomi, Akana. MuleSoft has some, and Tick.io also has one, and then SnapLogic is another new one. So these are different API gateway tools which companies leverage. I have used some of these tools and they are pretty much helpful. I have also used custom tools which people have built. They have built wrapper around it. But predominantly, whatever features I showed in the previous slides, they have been very helpful, and I use them day in, day out in my production application monitoring. And it helps us in identifying issues and nailing down and bringing productivity to our developer life for managing microservices. Now, coming to the trivia question which I had, we discussed a lot about API gateway, but there's also a load balancer which load balances different instances. Now, let me know, should the load balancer come before an API gateway or should it come after the API gateway? Do let me know in the comment section below. I will definitely respond to every one of you in the comments. Just to summarize what we just discussed, we saw what is an API gateway. API gateway facilitates communication between client and the server, and it helps in managing our APIs much better. We saw different components of the API gateway with respect to APIs, traffic management, observability, security, and health checks and discovery. We also saw why we need it. We saw with an example of a full delivery application how there are so many moving parts within a big system, and then if you want to communicate with each other, it is easier to offload some of our tasks into a central system or a gateway, which is called the API gateway. We can register all our APIs into their API gateway, and folks can go and consume off of that API. Finally, we also looked at some of the tools which we had in the industry, which you can leverage for creating API gateways within your services. I hope this particular video was very helpful. If you want me to make similar kind of videos, do let me know your suggestions on any new topics in the comment section below. I will definitely go do a deeper dive similar to it. If you want me to make a video on some other separate topic, do let me know that in the comment section as well. As always, if you like the video, go ahead and like it. If you haven't subscribed to the channel, go ahead and subscribe to it. Meet you again in the next video. Thank you very much.